G'day, my name is Bruce Robertson and this is Pirate Philosophy. In this series of videos I will be describing an original philosophy, one that you won't find anywhere else, but it is one that is logical, rigorous and dynamic. Welcome to Pirate Philosophy. In the previous video we looked at how a logical processor that has links to sense data and also to motor outputs can interact with its environment in order to benefit itself. And we looked at a number of examples of how this would work. And this is the very beginnings of how a logical processor can interact with the world. But it is far from the sort of way that we interact with the world. There is a qualitative difference between a simple logical processor interacting with the world in a highly mechanical way and the way that we humans interact with the world. So now we want to look at how that might be possible. For we have a model of the world. We have an understanding of the way it works, and we understand and see the world as it appears. And how can that happen with a logical processor? What else can be done with the data? I mean, you could add it together, play around with it, but if you're only interacting with the world in an entirely mechanical way, then you will only interact with the world in a mechanical way, in the way that computers do, or robots, or even what's called artificial intelligence today. It has no model of the world. We have a model of the world. And how can that be created? So what else can be done with the data? How is it possible for a logical processor, such as our brain, to create a model of the world? And I suggest to you the only way that this can be achieved is through a process of pattern identification. And of course, this pattern identification has to evolve from the simple logical processor that we looked at in the last video. How could it evolve? In that video I showed some bricks, and one of them was in the shape of a square, and we looked at how if the identification of that as a square might well benefit the particular organism. But of course it's not always going to see it as a square. Sometimes it might see it as a larger square, or perhaps a much smaller one, or perhaps a rectangle, or perhaps a rectangle the other way around. And the question is, are those the same as the original square, or are they different? A certain pattern needs to be created, will be useful at least. So now I want to skip several 100 million generations of evolution from our simple logical processor that interacts with the world in a mechanical way to a logical processor that is able to identify patterns, and then through this process to build up a model of the world. However, pattern identification is not a simple logical process. It is not a linear process in the way that the logical process for solving a mathematical equation is linear. You just take the equation and you apply certain rules to it and you end up with whatever you want, presumably a solution to your equation. Pattern identification doesn't work that way, and that's perhaps why it has generally been ignored in the literature. Mathematics doesn't, the discipline of mathematics has done very little with regard to the logical process of pattern identification. And the reason for this is that pattern identification needs the input of what is best described as a template. It's a possibility. It's something that might require imagination, or at a basic level it could be entirely random, but you have to start off with some sort of theory, if you like, a possibility, and then you test it to see whether it fits the data or not. And if it fits it very well, you move on. If it doesn't, you go back and you find a different template and you try that. So let's just look at a few examples. Take this sequence of dollar signs. Now, I'm sure you'll quickly recognize that the pattern, the unit pattern, the template, if you like, is $1. And then in order to recreate the data, you just reproduce that $. So the $, if you like, is a pattern for that particular sequence of dollar signs. Or you might have this sequence of $2 signs and a gap, another $2 signs and a gap, and then the pattern unit, obviously, is $2 signs. Or you might get slightly different ones like $, $, and then the pattern for that is $. And then you might get a sequence like $%, $#, for which again the pattern unit is $. One has to assume that perhaps the percentage sign is a spurious data point, or perhaps it is real, but you would then need more data in order to identify that that percentage data point was valid and that you want that in your pattern. And to some degree there is a balance between having an efficient pattern that's very simple and one that is accurate, or you can have a more accurate one that is perhaps not so simple. And then you might get the sequence $# at %, $# at %, and so on in a sequence, and for that the pattern would be $# at %, repeated as a sequence. What one is doing, in mathematical terms at least, in finding a pattern, is compressing the data. You are taking a long string of data and you are compressing it, so that in that respect the pattern unit I've displayed is a compressed form of the string of data. While this pattern identifying process is not entirely linear, it is nevertheless entirely logical, because you can write it as a simple algorithm, and that is very important for having a logical process. So you can have a simple algorithm, which is amass the data, input a template, test the template, does it fit? If it fits, continue, otherwise return to step 2 and input another template. And go around that loop until you run out of templates, or you've been around a sufficient number of times, or you're generally bored with it, you're not making any progress. And then store the template together with a label for the data. So you've got a simple algorithm for identifying a pattern. And people are very adept at finding patterns. A lot of people find mathematics and the manipulation of mathematical symbols very tricky. But whereas finding a pattern for data like some of the ones I've just shown you, people find it very easy. And that is an indication that we are on the right track in our journey for identifying the logical processes of creating a model of the world. And to show how fundamental this is, I would like to just show you another couple of examples. Take this example where you've got $, $, $, dollar, 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 etc. What is the pattern there? Well, I'm sure you can identify it. It's a dollar, and then for the sequence, the next one it's $2, the next one is $3, the next one is $4. And this can be linked to the organism moving towards its particular source of sense data. It could be visual, or it could be sound, or it could be aroma, smelling. And as it approaches it, the signal gets stronger. And in this way, it can identify the beginnings of space, a spatial recognition as it moves in a particular way towards the source of the sense data. It gets an impression of space. And another example here, I've got hash, 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 at, hash, 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 at, and so on. Obviously, you can identify what the pattern is there. It is hash, 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 at. And again, going back to our organism, this could possibly represent the sequence of day and night, light and day. It's light for a certain time, then it's dark for a certain time. Light for a certain time, dark for a certain time. And in this way, we have looked at the very roots of the identification of time and space. And it is interesting to note that standard Western philosophy merely labels time and space as a priori, whatever they mean by that, and just leaves it at that. We have looked beneath that to the basic logical processes of identifying what is time and what is space. But of course, in order to construct a model of the world, we need something more than just creating simple patterns from simple sense data. That's not going to be enough. We need something more. Maybe you can guess what it is. If you do, let me know in the comments below. Otherwise, we will be discussing it in the next video. Well, that is all I have for you today. If you have any interesting comments or questions about today's video, please leave them in the comments section below. And if you would like to continue this journey with me, then please subscribe to my channel, give it a thumbs up, and ring the bell. Thank you.